Alright, welcome back. So here is the bonus example for the simple pendulum. So here's the question sounds. A simple pendulum has angular the amplitude of theta max equal to 20 degree. So here is our amplitude. This is our amplitude, and it is also equal to theta max. Alright, and a period of t equal to 2 seconds. So this is the period. T is equal to 2 seconds. Okay, when it comes to mention of period, always relate to the omega. Okay, relate to omega. Alright, and then how long, the question is that says that how long does it take to swing from theta equal to negative 10 degree to theta equal to positive 10 degree. So when it say how long does it take, okay, this means that this question wants us to find time. Okay, want us to find time, and it says that it's swing from theta is equal to negative 10 degree to theta equal to 10 positive 10 degree. So here I will construct a diagram. I will draw the diagram so that means you can see what does that mean, swing from theta is equal to negative 10 degree to theta equal to positive 10 degree. I will show you now. So here, this is the ceiling and attached with the string. So here is the string. See, here is the position of pendulum at equilibrium. At equilibrium, when it says that at equilibrium, that means that theta is equal to 0 degree. Okay, now it says that swing from theta equal to negative 10 degree. So it means that the position of the theta is equal to negative 10 degree. It means that theta is to the left, right? So here is theta is equal to negative 10 degree. Okay, and then it says that it moved from negative 10 degrees to the positive 10 degrees. So here is the positive 10 degree. It is here. Okay, so that means that the question wants us to find how long does it take to swing from the negative 10 degree to the positive 10 degree. How long does it take? Okay, what is the time here? Okay, so in this question, I want you guys to form an equation of the displacement as a function of time first. So theta t is equal to a sine omega t plus pi naught. Okay, here we'll derive more. So theta t is equal to theta maximum sine, and then omega is equal to square root of g over L times with the t plus pi naught. Right? So here, as we can see, we know that theta max is equal to 20 degree, and we convert it into a radian, and you will get that 20 degree is equal to pi over 9 radian. Okay, and here we have the square root of g over L. Okay, square root of g over L, which is omega. Okay, so we know that omega is equal to, we have three what's that called, we have three ways to find omega. So the first one is omega is equal to 2 pi over t. Second one is omega is equal to square root of k over m, and the third one is omega is equal to square root of g over L. Okay, so in this question we know that period is equal to 2 seconds. So we can use the first equation to find omega. Alright, so omega is equal to 2 pi over t. So omega is equal to 2 pi over 2, right? So omega is equal to pi per second. Alright, now we have the amplitude. Okay, good. we have the omega. Okay, good. Now what is the problem? The pi naught. Again, always the pi naught. So in this question, I want to measure first at the equilibrium position. Here, okay, I want to measure a time from the equilibrium position to the second condition, to the negative 10 degree. What is the time here? Let's say that this is T1. Okay, what is the time here? Okay, so to calculate that, I want to ease up the calculation, so I say that pi naught is equal to 0. So the question is why? Why do I identify that pi naught is equal to 0? Why? Okay, here I will explain from the first beginning of the learning session. Alright, so let's say that I draw a graph here, which is the displacement versus time. Alright, so here is the theta, which is the measurement in radian, and we have the time, which is t, measured in second. Alright, and when I say that the pi naught is equal to 0, when you wrote back the equation, okay, we say that theta with the respect of time t, theta t is equal to a sine omega t plus 0, right? So we calculate that, we substitute a and omega, which is we'll get that theta t is equal to a, which is pi over 9 sine, and omega is equal to pi t plus 0. Okay, that means that the graph will start at the bottom here, and here start at the bottom, here up, and then move down and up back. And we know that at this top here, this is what we call as the maximum displacement. So here is the pi over 9, right here the maximum displacement, and here we have another maximum displacement, but in the what's that called, in the opposite direction, negative pi over 9 here. Okay, now I want to refer back to the amplitude. To refer back to the period. So what does period mean? From the definition, as I said, that period, okay, is how long does it take to complete one oscillation. Okay, so that means that here, as you can see, I draw a graph. Here is what we call one complete oscillation, from here and then here and here until here. This is what we call as one complete oscillation. Satu ayunan lengkap in Malay. Okay, so here we have here and here. So at here is where the time is equal to 2 seconds, because this is how it longs to complete one complete oscillation, which is t is equal to 2 seconds here, and at the middle here is where it is 1 second. Okay, now I will draw a simple pendulum. We refer back here. Okay, so here I said that this is the equilibrium position. Okay, and here is the maximum amplitude at the opposite direction, and here is another maximum displacement at the right direction. Okay, so here is 20 degree, which is pi over 9 positive. Okay, and here we have negative pi over 9. Okay, so here we have, in this graph we have the four, I call this as a 4 tier. Okay, this is what I call the first tier, this is the second tier, this is the third tier, this is the fourth tier. Okay, the first tier says that at the bottom, which is theta is equal to 0. Okay, theta at the time 0 is equal to 0. Okay, theta at the time 0 is equal to 0. Okay, and it starts to rise up until maximum amplitude at the right direction. Here is where it means from 0, which is theta equal to 0, and here is theta is equal to pi over 9. That means then from here it will start to move to the right. This is what I call the first tier. Okay, so and then after that it moves in the second tier from the top to the bottom. That means that it comes back to the equilibrium position, which is right here. This is what I call the second tier. Okay, and then from here now we move on to the third tier, which is from the bottom to the maximum amplitude, but at the opposite direction. So that means that from the equilibrium position to the maximum displacement at the opposite direction. So this is the third tier. And then the last one from the top to the bottom to complete one oscillation. So from the maximum displacement to the equilibrium position. So this is what it means that this is one complete oscillation. So here I will recall it back. Okay, one, and then 2, 3, 4, 5 complete oscillation. That's what it means. So here, as I mentioned that theta at the time 0 is equal to 0. Okay, so I can substitute at the time 0 is equal to 0. Sorry. I can actually calculate from theta at what time to get negative 10. Okay, negative 10 degree. So theta at what time, we don't know what time is it. So here we want to find from this position, equilibrium position, to this position. This is what I called it as a T1. From here to here is T1. Okay, so theta at the time T is equal to A sine omega T plus pi naught. No, we don't need pi naught. Okay, because we are now at the equilibrium position. Okay, now we want to find at how long does it take to from equilibrium position to the theta equal to negative 10 degree. Okay, so here I said that equal to negative 10 degree. Okay, so A is equal to theta maximum sine and then square root of G over L is equal to negative 10 degree, and then theta max is equal to pi over 9 sine, and then square root of G over L is equal to our omega. Where is omega? Omega here. Okay, so pi t is equal to negative 10 degree. As I said that theta, I said that please change this form into a radian. So negative 10 degree, we will get that equal to negative pi over 18. Okay, so this is pi over 9 sine pi t. Alright, and then sine pi t is equal to negative pi over 18 divided by pi over 9. So we get that sine pi t is equal to negative 1 over 2. And then pi t is equal to sine inverse negative 1 over 2. And we get that pi t is equal to negative 0.1, negative pi over 6. Okay, and then t is equal to negative pi over 6 divided by pi. So we get that t is equal to negative 0.167 second. But now it is time, right? Time in time, we don't have vector. This is not a vector quantity. So we have to modulus it. So we get that time is equal to 0.1767 second. This is time 1. Okay, time 1. Okay. Now we want to check how long does it take from equilibrium position to this position. So theta t is equal to pi over 9 sine pi t, which is equal to positive 10 degree, right? Okay, so pi over 9 sine pi t is equal to, so change 10 degree to the radian form, so which is pi over 18. So sine pi naught pi t is equal to 1 over 2. So pi t is equal to sine inverse 1 over 2. So we get that pi t is equal to 1 over, because I'm so tired. Okay, sorry. So pi over 6. Okay, so t we get that 0.167 second 2. This is time 2. Okay, time 1, time 2. So here is what time 2. Okay, so to get that from here to here, we have to add both of this time. Add both of this to get this. Okay, so what is the time from theta equal to negative 10 degree to theta is equal to positive 10 degree, which is equal to t1 plus t2. We add up the two time, right? So t1 is equal to 0.167 and t2 is equal to 0.167 So we get that t is equal to 0.334 seconds. So this is how it calculates. So this is how long does it take to swing from the theta equal to negative 10 degree to theta is equal to positive 10 degree. So that is all, everyone. So I hope you understand, and thank you and have a good night.